All right, this is the beginning of a brand new unit, and this is the beginning of something that is so much larger, but we got to get some vocabulary behind us first. And the very first thing you need to know is, what is a sequence? And a sequence is going to be a list of numbers. Okay, I'm going to pause right there. This list of numbers is going to be, basically, a sequence, and each number is called a term. So these are called terms, so that's going to come in handy, with a pattern. So there'll be just some pattern to it. You can scroll up a little bit and see what's about to happen. 5, 11, 17, 23. That's the sequence. There's a pattern. You're adding 6 every time. Excuse me. I get choked up talking about this stuff. All right, I think I'm good now. A series, I'm not going to start over. I'm having too much fun. A series is the sum of a sequence. What in the world do you mean? Well, if I take a list of numbers and add them together, instead of putting commas in between them, I put plus signs, for example, then I would have a series. The explicit formula is the formula that expresses, wow, it'd be great if I could spell. Expresses has one P. Expresses okay, I'm gonna stop right here before I finish the sentence and we'll talk about what's about to happen. Even though no math has happened yet. If something is explicit, normally we think of it as being vulgar, but basically in its most pure form, and I'll probably say this again later in another video, but in its most pure form, to be explicit is to be direct. And so an explicit formula will take you directly to whatever term you want to get to. For example, if I gave you this list and I said, hey, what's the 12th term? Instead of counting first term, second term, third term, fourth term, fifth term, sixth term, that just takes too long. There would be a formula that would take you directly to whatever term you want. And we usually let the variable n represent the term number. For example, n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, n equals 6. So the formula that would express any given term would express the nth term. Okay, good to know. A partial sum is the sum of a set number of terms. You'll probably hear this referred to more frequently as a finite sum because we're just taking sum of the numbers and adding them together. We're taking a finite number of them. An infinite sum, you can see where this is going. This is the sum of all of the terms. All of the terms? What do you mean? All of the terms of an infinite series. And pretty much every series we're going to deal with is infinite, but I wanted to make that clarification this time, just in case you ever encounter one that just stops. I don't think I ever have, but just in case. There we go. So let me clarify what an infinite sum is. Basically, if I took 5 plus 11 plus 17 plus 23 plus 29 plus, and you keep on going, then it would be the sum of all those. Now, in this case, you're going to get infinity. But there are going to be situations, and you will encounter them in this lesson, where you can add up an infinite number of numbers and you will not get infinity because the numbers will be getting smaller so strategically and with such a pattern that it will get narrowed down to one specific number. Okay, a convergent series is a series with an infinite sum. That's the very basic definition of it, which is what I just said. If I added up a whole bunch of stuff, not this one, I'm pointing at the wrong one, but if I add up a whole bunch of stuff and I get a number, if I add together, oh, it's not on that page. Where is it? Where is it? It's not the next problem we're going to do, but the one after that. If I add these up, I'm going to get a number, and you'll see it when we get to this video, but if I added 1/3 plus 1/9 plus 1/27 plus 1/81 plus 1/243, and we keep on going, you're actually going to get a number, not infinity. And so this one is a convergent series, and I will say that later when we get to it, but a divergent series is basically a series without an infinite sum, which would be this. because if I added forever, I would basically get towards infinity. So a series without an infinite sum. Okay, there's one definition or one vocabulary word that I have left off of this, and it deals with how we express the formula, and it's called a recursive formula. We're going to encounter it in one of the examples that we're going to do in a few minutes. But basically, an explicit formula takes you directly to whatever term you want. The recursive formula is going to only get you there one at a time. We don't use the recursive formula much, which is why I left it out of this list.